So in this video, we're going to tackle a few problems involving density. The problems that we're going to try are all off of the New York State Regents exam. From earth science, you've learned that density equals mass divided by volume. And here we've talked a little bit about how if we multiply by the volume on both sides of the equation, we can come up with this formula that mass is equal to density times volume. And that's the more frequent formula that we'll use in this course. This was one of the more difficult Regents problems that I've ever seen, to be honest with you. It says that new street lights will be installed along a section of the highway. The posts for the street lights will be 7.5 meters tall and are made of aluminum. The city can choose to buy the posts shaped like cylinders or the posts shaped like rectangular prisms. The cylindrical posts have a hollow core with aluminum 2.5 centimeters thick and an outer diameter of 53.4 centimeters. The rectangular prism posts have a hollow core with aluminum 2.5 centimeters thick and a square base that measures 40 centimeters on each side. The density of aluminum is measured at 2.7 grams per cubic centimeter, and the cost of aluminum is 38 cents per kilogram. If all posts must be the same shape, which post design will cost the town less? How much money will be saved per streetlight post with the less expensive design? So we have a lot going on here. The first thing that we want to do is to determine the volume of the post. So to determine the volume of the post, and there are two different types of posts. I'm going to start with the one that they talked about first. They talked about the cylinders. So with my cylindrical post, I'm going to have those circles at the bases. And it says that it's going to have aluminum 2.5 centimeters thick. So that means that I have a circle within my circle. And right here, this thickness right here is 2.5 centimeters. It says the outer diameter is going to be 53.4 centimeters. So that means the entire distance across from here to here, right here, is going to be 53.4 centimeters. And that's the diameter. So to get the radius, I have to divide 53.4 by 2. So maybe I get out my calculator, because I think I'm going to have a lot of calculations to do in this problem. 53.4 divided by 2, and I come up with 26.7 for my radius. Now that's the radius of the outer shell, right? From the center to the outer shell is going to be 26.7, but I also have an inner radius, right? I have two different radiuses. So I have the outer radius, and then I have an inner radius that goes to the inside of the shell, which is going to be 26.7 minus that 2.5 of shell. So that will be 24.2. To get the volume of the post, I have to calculate the outer volume and the inner volume and then subtract them. So for the volume of a cylinder, that's equal to the area of the base times the height. No divided by, because there's two bases. Area of the base times the height. So the base is a circle, so we're going to put in pi r squared in for the area of the base times the height. So for the volume of the outer shell, we're going to have pi times 24.2, no, outer 26.7. I started with inner. So we're going to put in 26.7 squared times the height. Well, the height of the post is supposed to be 7.5 meters, but all of this is measured in centimeters. So I have to multiply this by 100, or move the decimal place 2 places to the right. So we're going to have 750 centimeters. So times 750. So again, I'm probably putting this in my calculator. So I'm going to have pi times 26.7 squared times 750. And I'm going to get this gigantic number, 1,679,707.49. And that's my calculator rounding to the nearest hundredths place. And that would be measured in cubic centimeters. For the inner volume, I'm going to have pi times 24.2 squared times 750. So on the calculator, I can type second entry because the only thing that's changing is the radius. I'll put in 24.2, the 750 stays, the pi stays, and here I'm going to come out with 1,379,881. Oh, I don't need to type that again. I'm writing it over here. 881.741. So for the volume of the shell, that'll be equal to the volume of the outer minus the volume of the inner. So on my calculator, I'm going to do 1,679,707.49 minus the previous answer, and that'll give me 299,825.748. And again, that's centimeters cubed. And all that we've done so far is calculate the volume of the shell. That's it. That's all that we've accomplished. Now I have to do the exact same thing with these rectangular prisms. With the rectangular prisms, we're going to have the square base, and it's still going to be 2.5 centimeters thick. So I'm going to do my best to draw that. Square base, 2.5 centimeters thick, same thickness that we had before. So this right here is 2.5 centimeters. And it says that the square is going to measure 40 centimeters on each side. So 40 centimeters here, 40 centimeters here. If this is 2.5 and this is 2.5, I'm really taking away 5 centimeters, right? 2.5 plus 2.5 is 5. So this is going to be 35 by 35 on the inside. So the volume of a rectangular prism is area of the base times height. And since my base is a square, I can do side squared times height. So for the outer shell, I'm going to have 40 squared times that height, which we already calculated, right? Because the heights have to be the same. It says 7.5 meters tall. So this will be 750 centimeters tall. So I'm going to have 40 squared times 750 for my outer volume. So 40 squared times 750. Looks like we're at 1,200,000. For the inner shell, I'm going to have 35 squared times 750. 35 squared times 750 is 918,750. If I subtract those, the volume of the outer minus the volume of the inner, that's the volume of the whole shell, the volume of the shell. So 1,200,000 minus 918 281,250 cubic centimeters. So the first question that they ask is, if all posts must be the same shape, which post design will cost the town less? Well, the post design that's going to cost the town less is the one that's smaller, because you pay based on volume. So we can automatically say that the rectangular post light, where's their wording? The post shaped like rectangular prisms will cost less. So we can already answer that section. The posts shaped like rectangular prisms cost less. Then we're asked how much money will be saved per streetlight post with the less expensive design. So to determine how much money is going to be saved per post, we have to figure out the cost of the post. So the first thing that I would do is I would calculate my mass. So to calculate the mass, I'm going to change color for a second. The mass is equal to the density times the volume. So for my rectangular mass, right, the mass of the rectangular post, I'm going to take the density, which they said was 2.7 grams per cubic centimeter, and multiply that by 281,250. So I already have that number saved in my calculator, so I can just say times 2.7 and come up with 759,375. 759,375. So that's grams per cubic centimeter. It says that, so this is grams, right? This is grams. It says that aluminum costs 38 cents per kilogram. So to change grams to kilograms, I have to move my decimal to the left 3 places. So when I move my decimal to the left 3 places, I can say that this is 759.375 kilograms. And I'm going to multiply that by 38 cents per kilogram times that 38 cents per kilogram. And that will give me the total cost of this rectangular prism. The cost of the rectangular prism. So I'm going to take 759.375 and multiply that by 0.38. So that's going to be $288.56. $288.56. I also have to figure out the cost of this prism over here. Well, this isn't a prism, the cylinder. So we're going to go through that same process again for the cylinder. In order to do that, I'm going to find some space. So mass is still equal to density times volume. Density is still 2.7. So I'm going to take the mass, and in this case we're going to find the mass of the cylinder. We're going to do 2.7 times this volume of the shell. Volume of the shell. So when I do 2.7 times the volume of the shell, I'm going to have 2.7 times 299,825.7488. Because we know it's dangerous to round before we get to an answer. So we're going to have 809,529.5218. Now, to get my cost, I have to change this to kilograms, right? Because this is in grams. So when I change to kilograms, I move the decimal 3 places to the left. And I would say that it would be fair to estimate and round and go to 809.529 and that's in kilograms. We're going to multiply that by the 38 cents per kilogram. 38 cents per kilogram. So I'm going to get my cost equal to 809.529 times 38 cents is $307.62. $307.62. And they want to know how much is going to be saved. So if we have to figure out how much is going to be saved, we have to subtract these dollar amounts. So I'm going to have $307.62. I'm going to subtract $288.56. And I can subtract those fairly easily, right? I have 6 cents here. I'm going to have to do 17, so I'm going to have a 9. And I borrowed from a 10. So I have a 9 minus 1. $19.06 is how much money we saved. As I said before this problem, I think that this was one of the hardest problems I ever saw in a Regents exam. So if you're able to figure this out on your own, that's something that you should be really proud of yourself. Hopefully I will show you another density problem at some point in the near future.